Okay, so let's talk about real quick on how is that we would interface or work with DOM with the with XML documents. So this hierarchical representation of XML documents is also referred to as the DOM, or the document object model, meaning that this ASCII representation, this text representation of the data, at some point needs to be parsed by by some parser using specific classes and interfaces and whatnot. And in memory, it's going to create a representation, in-memory representation of all these elements and attributes and whatnot. So the in-memory representation of this document, right, is referred to as the document object model, right? And there's a standard, there's a W3C standard, right, that declares what are all the classes and interfaces that allow you to represent all the different portions of an XML document. And standard defines classes and interfaces such as root element, elements, attributes, values, string values, represents list of nodes. Certain nodes are attributes, certain nodes are elements and whatnot. So the W3C maintains this standard, right? And it's the in-memory representation is referred to as the document object model. So let's take a look at how is it that we could interact using Java and manipulate, either read or update these XML documents. So the JavaX XML package, right, contains all sorts of really cool Java classes that allow us to interact with the XML language, the XML documents. Now, in addition, we have the classes and interfaces in the package org W3C DOM. Right, this is a set of packages that are part of the standard, the W3C standard, and are fully implemented in Java. So we're going to be using these two packages to be able to interact with an XML document. So let's take a look at an example. Here we have a really simple XML document, right, where we have a root element called students, and then we have underneath, we have two students inside this top level root students. The students are Alice and Bob, and they have a different unique identifiers. You have ID 123, ID 234, and then you have first name, last name, and username. So one way to interact with this very easily is that we would use the JavaX XML package. In there, we have several parsers that can open up a file, an XML document, read it into memory, right? And once it parses it, it generates these W3C instances for the root document, and then all the lists of nodes that are pointing to each other, creating this hierarchical structure. So let's just take a look at a real quick example. So here we're going to read the student XML file. We use the DB factory, document build factory that is used for parsing an XML document. So it takes the students.xml. It normalizes. And normalizing means that it's going to make sure to remove any excess white spaces, and so that it can be then parsed correctly. Once it's parsed, you can then ask for the W3C documents. Here, this document, there's this document over here. So the document builder, which is under the JavaX XML package, generates for us. It parses the XML document and it generates for us a W3C interface, right, that represents the entire document. Once you've got this document, then you can use the APIs in that document to traverse this document, right? Traverse the hierarchical structure. Like for instance, you can get the root node, right? So starting from doc, if you get the document element and get the node name, you will get the here, the root element, the students, right? So once you have that, you can also ask for, starting at a particular node. You can then ask what are the children of that node, right? You can ask the API to traverse the tree looking for specific elements in that tree, and that's this traversal of the tree is the equivalent in relational databases as doing a select statement, right? When you do a select statement, right, in a relational database, is basically you're asking the database to iterate over all the tables, looking, well, not a specific table. You can say, select yada 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 from and then the table. You're asking, hey, iterate over that list of tables, looking for those elements, those records that meet a particular criteria. So here we have the same thing, right? We're asking, doc is the equivalent of the schema, right, of the particular database, right? And but here, instead of having multiple tables, what we have is multiple nested elements. So the equivalent of breaking up in relational databases, breaking up one single table, breaking it up into multiple tables, and that we call that normalization. The equivalent here in XML is to instead create more nestings, right, of elements within more elements within more elements. So the operations are equivalent, right? That we are normalizing, we're breaking up the data space, right, into multiple tables. The equivalent in XML is that you create more hierarchical, more nested elements within elements. And the operation of joining, that we have in relational databases, where we traverse not just one table, but we traverse multiple tables, and we identify, which foreign keys are equal to which primary keys. We don't have that equivalence here in XML. Instead, it's all inside nested elements, right? But it could be that nested elements under one path of the hierarchy are somehow related to some other elements in some other path of the same document. And so we need to be able to iterate over all the elements, finding which XML elements are related to some other XML elements. Okay, and so the API allows you to retrieve all the elements that have a particular tag name. So for instance, you can say, give me all the students, right? So retrieve all the elements that have the name student, right? So same thing here, right? You could say, give me all the courses or course, right? And it would come back with a listing of all the elements that meet that criteria. So you can specify that criteria, right, and return data from the XML document. So here, one of the most simplest criteria, right, is that if you give me the name of the tag, I'll go and iterate over the XML document and retrieve all those elements that have that tag name. So in here, what we're doing is that we're iterating over those students, and you can also ask what the type of the node is, because some nodes nodes in the tree are full-blown elements, and some nodes, right? Notice these attributes; those are also represented as nodes in this DOM hierarchical tree. So this might be an attribute, whereas student might be an element. So you can ask, when you retrieve these nodes, what are you? Are you an element or an attribute, right? If you're an element, then you have a body. You might have sub-elements. If you're an attribute, you can have sub-elements, right? You just have a value, okay? So as you traverse this DOM, right, you can ask yourself, well, where are you? In this case, we're iterating over the student nodes. We're checking to see that they are element nodes. If they are, we're going to cast the node into an element node. And once you're an element, well, elements can have attributes, right? But attributes can't have attributes, right? But elements can have attributes. So here, because I'm an element, a student element, I can ask, well, you can have attributes underneath, right? I can retrieve the ID attribute. I can retrieve the first name attribute, the last name attribute, the username attribute, right, as nodes, and then get the values for each one of them. So here we are converting each one of those nodes into elements, and then asking the values of those nodes, right, the first, the last, the username. Okay, so here's another example of using movies. I'm not going to go into it. I'm just, you can take a look at that on your own.